In our previous video, we discussed the Qtum blockchain. One of the main goals of the Qtum team was to build the first UTXO-based smart contract blockchain with a proof-of-stake consensus model. The foundation for Qtum's code is Bitcoin's blockchain, but the Qtum developers abstracted and added layers on top of it to allow the Ethereum virtual machine to process smart contracts on top of Bitcoin. As such, Qtum benefits from new developments in the Bitcoin and Ethereum communities, and smart contracts built on Ethereum can easily be ported over to Qtum as well. Qtum has a major advantage in the sense that it is backwards compatible. This means that it can absorb and thus take advantage of improvements in both the Bitcoin and Ethereum blockchains. This would mean that Qtum is compatible with the scalability solutions suggested for Bitcoin, such as the Lightning Network, as well as any scalability solutions suggestions for Ethereum, such as state channels or Plasma. Any developments in the Ethereum or Bitcoin blockchains can be incorporated into the Qtum blockchain with the consent of the Qtum community. In our last two videos, we discussed how Qtum uses the UTXO model. In this way, it is possible to transparently trace back the history of every transaction through the public ledger. The UTXO model's stateless environment also encourages users to use a new address for every transaction, thus improving privacy. We discussed how Qtum makes use of the proof-of-stake consensus model, but uses an advanced version called POS3. POS3 is an improvement over version 2 that was developed and implemented in the Blackcoin project. Some minor details were modified by the Qtum team, but the core consensus model is the same. We discussed how the value of your stake affects your chances of being selected as the next validator. The higher the stake, the higher the chance. In order for the process to not favor only the wealthiest nodes, some unique methods were added into the selection process. Two of these were randomized block selection and coin age selection. Randomized block selection looks for a combination of the lowest hash rate and the highest staking value. Coin age selection considers how long the tokens have been staked for. The longer you stake, the larger your profit would be. Proof of stake was a good improvement over proof of work, but it came with a loophole. People who stake their coins could keep their node offline. Online nodes are required to ensure a healthy network, but by turning their nodes off to save on operation costs, stakers could cheat the system and weaken it at the same time. POS3 encourages stakers to keep their nodes online at all times to receive a staking reward. People with fewer tokens who keep their node online could receive a staking reward relative to people with many tokens who keep their nodes offline. Qtum, unlike most other staking coins, requires no minimum balance for staking. This makes staking rewards accessible to a larger group of participants by lowering the barriers to entry. In our previous videos, we discussed how Qtum uses the Ethereum virtual machine, or EVM, and how it allows for any Ethereum smart contract to be run in Qtum and vice versa. Solidity can thus be used to write contracts for Qtum, just as it can be used to write contracts for Ethereum. This makes it easy for Ethereum developers to develop dApps on Qtum. Existing Ethereum dApps can also be ported to Qtum. This encourages Qtum adoption amongst blockchain developers. In our last video, we discussed the incredible piece of engineering that is the Account Abstractions Layer, or AAL. The AAL doesn't only allow the EVM to live on top of a UTXO blockchain, but it also means that Qtum does not have to be confined to using only the EVM as a smart contracts platform. Any other smart contract virtual machine that is compatible with Qtum's AAL can be used to replace the EVM. Qtum developed their own revolutionary x86 VM. This allows developers to program smart contracts in the majority of popular programming languages instead of just Ethereum Solidity. Popular languages include C, C++, Java, and more. When developing their version of Bitcoin Core, Qtum made changes which became known as Decentralized Governance Protocol, or DGP. DGP allows Qtum holders to vote on changes to a limited set of blockchain parameters, such as block size and block time, without necessitating hard forks. This allows Qtum to better adapt to changing network conditions and allows for a quick recovery from certain attacks on the network, which are issues with both Bitcoin and Ethereum have suffered from in the past. Both Bitcoin and Ethereum have both hard forked due to changes in block size. Qtum can prevent a fork by handling this decision using DGP. All the above benefits summarize just a few reasons that we believe developers might prefer Qtum over the Bitcoin or Ethereum blockchains, and that could increase the adoption of Qtum in the future.